So guys, welcome to my talk. Woo! We're gonna discuss the big title with a big name, Confidential Transactions on Ethereum. Hopefully you guys are not too scared about this title. We're gonna break it down. But first, who am I? So my name is Aurora Poppyseed, or at least I'm known for that name in the crypto space. I'm a DevRel at Zama, a self-proclaimed hackathon expert, and I've been in blockchain since 2022. Before they called me a newbie. Now I'm already, the space is evolving so much that I'm already kind of to go to the grave, but So my handle is poppyseed.dev. If anybody wants to reach out, you can. All right, what's gonna be the agenda of this talk? So we're gonna go through 3 points. First, we're gonna talk why blockchain fails at confidentiality. I'm gonna try to convince you that this is actually true. Then we're gonna look at the problem. We're gonna put ourselves into the shoes of designers of a protocol, and we're gonna see how would we solve this. So how would we solve on-chain confidentiality? And then when we're gonna solve it, we're gonna look at the result, and we'll see what is the result of this. So hint, the ERC20 token that you're all very familiar with will become confidential. All right, let's get started. But before we get started, what is actually confidentiality? So we like to interchange the two words between each other, confidentiality and privacy. When we're referring to privacy, we're actually referring to rights of individuals. And when we're referring to confidentiality, we actually are talking about obligations of those who manage information. So for example, when we are talking about banks are actually managing your information. Banks should have confidentiality. So when you go to a doctor is obliged to actually keep your information confidential. Why am I saying this? It sounds a bit dull, but actually it opens up so many different applications, right? We have Raycash here. I mean, you guys are solving everything, so let's go. And then we have also a lot of other people and things, projects that are actually building on Zama and are using our technology to do this. So in between, it's protection of actually sensitive information. All right, now let's see the problem. Blockchain fails at confidentiality. Is this actually true? Well, we all know that basically all information on blockchains is actually exposed. So when you're going on a normal blockchain and you're interacting with different wallets, you're going to some entry point. For example, you're going through some provider, you're interacting, you're inputting your details. Sooner or later, all your data, everything is actually exposed. So people who actually have the on-chain information, well, they can see who you are, and exactly because your addresses are associated with how much money you have, they can see how much money you have, where you went, what do you spend, who is spending on who. If you have a lover, you spend so much money on your lover, that's not good, right? And of course, we have our little thief here who can actually target you and steal your information. So what do we want? We want a public blockchain. However, we don't want the information to be revealed, so we want the information to be actually confidential. All right. So how do we solve this, right? How do we put ourselves in the shoes of a designer and solve this problem? Well, actually, I'm going to try to convince you that we need a universal key. So we need a universal key with which we can unlock every data. For example, if I have actually a normal key myself to unlock some information, all right, it's encrypted, right? I can put it on blockchain, no problem. However, if I want to transfer it to you over there, well, we have a problem, right? What, should I decrypt it and then send it to you? Well, no, because everybody would see it, right? So we need some universal key. This universal key, well, we can use it to basically to encrypt this information and unlock it for you. So this is how it would look like in practice. So we have this 1.2 million, and then we have a universal key with which we actually lock this information. So the result would be this 1.2 million that's locked. So the result would be just like a hash. So everybody wouldn't see what's the actual information, but they would just see the hash. So where would we actually store this universal key? Well, we could try storing it on blockchains. We could actually try to store this information on blockchains. So this universal public key, we could try to store it on a blockchain, but that actually won't work because, well, we know what a blockchain is. It's a bunch of nodes, a bunch of computers everywhere that have duplicated information, and all information is actually public. So if we store it there, we're practically just showing the universal key to everybody. So that won't work. Then another solution some guys came up with, we are not talking about TEs and so on. And we say, oh, how about we put this universal key on a server? Well, server is also not really good enough. So how would we basically solve this in this kind of scenario? We would have a blockchain here, we would have a server here, the universal key would be on the server itself, and then this would basically communicate between each other. Well, this won't actually work, right? Because here we have a thief, and actually, for example, this could be even a manufacturer if we would have a TE, or somebody in the process that would actually steal this information, right? So that's really bad. We don't want that. So what could we do? How could we solve this problem? Well, I will argue that we could actually have the key and split it in multiple different parts. And once they interact together, they actually produce the universal key. So we have these keys. We put them each on a different computer on quotation marks. And once these computers interact between each other, they actually can send information, can decrypt anything, and they're off the blockchain. So they're living off the blockchain. So everything is off chain, right? So if somebody steals this key, well, they cannot actually access the information because, well, they're not able to, right? They need all the other pieces to actually perform this decryption. All right, so this is kind of how Zama's architecture looks like behind the scenes in a very simplified manner. But this is not the whole picture. Let's see what the problem is now, right? So we figure out how do we store this universal key. Great, we're good, right? How about if we want to change an encrypted balance? So for example, here is Alice, and it's transferring $10 to Bob, right? Or 10,000 Argentinian pesos to Bob. So what is actually happening on blockchains? You have some balance, and then you are subtracting 10 euros or $10 or 10,000 Argentinian pesos from Alice's account, and then from Bob's account, you are actually adding up 10,000 Argentinian pesos. So this is actually an encrypted computation that has to happen, right? Otherwise, if you imagine like in the traditional sense, okay, so I want to do this computation, well, I would actually have to get this information, have to get the storage that you put on the chain, decrypt it, do the computation, bam, encrypt it again, and put it on chain. Oh my God, that doesn't make any sense, right? Like, what's the point of it, right? Then we could just have another server and we would be done, right? So somebody would actually have to reveal the information. So we need a solution for this. I would argue that fully homomorphic encryption is the best solution for this. So fully homomorphic encryption actually allows us to do computations on encrypted data. So how does it look like in practice? Nothing scary here. We have a public key. We have a private key that you're used to from MetaMask and so on. So public key actually encrypts information. Private key decrypts information. And then we have with FHE another key, which is an evaluation key, that takes two different encrypted numbers and creates another one. So, for example, before we're saying like, oh, Bob has 100,000 Argentinian pesos. We add 10,000 Argentinian pesos to his account. Bam, now he has 110,000 Argentinian pesos. All right, cool. Now we can do a lot of things. So what does Zama actually do? Well, Zama actually allows us to build confidential applications on any blockchain. So, what we started with Zama, we basically started from a TFHE RS library. We started very simple. Okay, we're gonna just put fully homomorphic encryption into a Rust library. That was very successful, actually. But then we said, okay, let's go more complicated, right? So we started a bit with machine learning. We saw, okay, this is not the best fit. How about blockchains? Blockchains are perfect fit for FHE. So our main library is now FHE VM, and you guys can actually interact with it today. So we are now, what's our status? We are now available on testnet. We'll be available on mainnet by the end of the year on Ethereum, and then on other EVM chains and Solana next. So let's look at the result together, what happens. So what happens is that the ERC20 token that you are also familiar with, that is in all the different applications from, DeFi to banking to blah, 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 that you all trade and so on. This ERC20 token will now finally become confidential. So what does that mean? Well, when I'm transferring you some money, well, nobody will know how much money we actually make. So what we did, we partnered with OpenZeppelin, and we created the ERC7984 standard, taking the ERC20 tokens that you all know and creating making them confidential and creating the ERC7984 standard. So how does this look like? You're all familiar with the ERC20 token generation if you did a little bit of development. So what you would create here, you would input the library from OpenZeppelin, you would create the token, mint the initial supply, bam, you're done, you have created your gold token. Now, if we check the ERC7984 implementation, we would use FHE Solidity library. This is the library that Zama developed. We would create the configuration for Sempolia. We would import our confidential token library, and then we would mint the initial supply. Bam, token created, confidential token created actually. So how would the output look like in the end, right? So this is our ERC20 token, this is our ERC7984 token. For the ERC20 token, well, when we say balance of, we get 20 tokens. And then when we say, okay, can you fetch me the balance of the confidential balance of Alice for the ERC7984 token, everybody would just see hash. So they wouldn't know what the information actually is. Only Alice, because we allowed her to actually decrypt this information, she could actually decrypt this information. Okay, cool. How about if we want to actually create some other applications? Well, this is now also possible. So yeah, sure, you can make private transfers with the confidential token, but then you can also create a blind auction, you can do some confidential voting, you can have some encrypted DIDs and so on. With the blind auction, you actually guys have tested it out with the berries. So when we tried to onboard you, this is what was happening behind the scenes. And of course, you could create anything with the encrypted types we offer you. So if we guys want to now know a bit, okay, great, I'm onboarded. How should I start coding? Well, we have a few resources for you. We have the Open Zeppelin confidential contracts that I mentioned before. This is a library that has multiple different contracts that are ready, basically audited and everything, ready to go. Then you can look on the documentation for Zama, docs.zama.ai. And of course, when you are hackers, just getting started and creating something quickly, you can go to GitHub to the FHEVM React template. And of course, actually, if you want to try to, when you create something nice, I would actually tell you to be onboarded on the Zama developer program. We actually flew somebody to Argentina, Buenos Aires here, and gave them the golden ticket. So thank you. And actually, I would urge you to try the developer program and the Zama protocol. You can scan the QR code to go to the documentation. So I'm going to just show you this. So this is the architecture overview that Clement is going to have a talk later on. And you should definitely listen to him. He's going to go much more into details than I went. So thank you a lot and try the Zama protocol.